This video is going to cover area of composite figures. What a composite figure is, it's going to be a figure that can be broken down to separate regions, creating basic figures. In other words, it's a figure created by two or more shapes. So what we'll end up doing is separating it into the different shapes that we have area formulas for, and then either add or subtract depending on the problem. So the first problem we already have these three columns here, and I went ahead and wrote in the three shapes, and it says it in the problem. Say it's comprised of a semicircle, a regular hexagon, and a trapezoid. And so what we're going to do is we're going to find each one separately, and then since this one is all combined together, you'll see later how when we'll be subtracting, at the very, very bottom, we already have it set up to add them. So let's go ahead and find the semicircle first. Semicircle, the formula is pi r squared over 2. Pi r squared is a circle. We have half a circle, so we have to divide that by 2. In this problem, we're seeing here the diameter is going to be the same length as the hexagon side lengths, and the hexagon side length is 9 centimeters. So your diameter is going to be 9. We need the radius, which is going to be half of that of 4.5. So we plug in. We have pi times 4.5 squared over 2. We plug this into the calculator. The problem is asking us to round to the nearest hundredth, 2 numbers after the decimal. So the area of our semicircle is going to wind up being 31.81 centimeters squared. So I'm going to go ahead and put that down here as well in our addition area. And let's take a look at the hexagon. So the hexagon is going to be a regular polygon, so we have to find the apothem and the perimeter, multiply them, and take half of that. So with this, we are going to have to go ahead and find our apothem. When we have the center, well, I'm going to go ahead and draw in some radii here, and then we're going to have these right triangles. So finding that apothem, whenever we find that central angle, it's going to end up being 60 degrees. So this right triangle will be half of that of 30 degrees. So we have a 30, 60, 90 triangle. The base down here, this other leg, is going to be half the side length of 9, so it will be that 4.5. So to find this, we can either use trigonometry or your 30, 60, 90 triangle. I'm going to go ahead and use trigonometry on this one. And so whenever we see here, we're going to be using A adjacent, A for apothem, and the 4.5 is going to be the opposite side. A and O are going to give us tangent. So we take the tangent of 30, our reference angle right here. This will be equal to opposite of 4.5 over your apothem. We set this up proportionally and cross multiply. We wind up with A times the tangent of 30 equals that 4.5. So we're going to find ourselves dividing. And if you are using your trigonometry, always make sure that your calculator is in degree mode. And the apothem will come out to approximately 7.79. Now for the perimeter, we have 6 sides of a hexagon multiplied by the side length of 9. Our perimeter will be 54. So we will now plug this into our area formula. We have our apothem, 7.79, times the perimeter of 54, all over 2. And this area will come out to approximately 210.33 centimeters squared. If you use the special right triangles, 30, 60, 90, and you use the radical instead, you're going to wind up with 210.44. Just heads up if you're deciding to use it that way, so maybe a little bit off, and that's okay. Now we'll look at the trapezoid. The trapezoid is going to be right here. We have base 1, base 2, and height. Well, base 1, right here, again, doesn't matter which one's base 1 and base 2, but right here is, again, the same as the side length of the hexagon of 9. The other base will be 15, and our height is listed right here, right here at 19. So we'll go ahead and plug everything in. Base 1 plus base 2 times height We plug this into the calculator, and we're going to wind up with 228 centimeters squared. Down here, we'll go ahead and add that. When we add all three of these together, we will find this to be 470.14, and it already has centimeters squared listed there for you. All right, number 2, we are going to have to draw in lines on our own. They're not giving us the lines like we did on the last one. We're going to round to the nearest tenth. So what we need to see here, what shapes do we have? Well, we can draw a line in right here, and we've got a square. We can draw another line right here. We'll have a trapezoid and a semicircle. So let's start off, since they are all shaded, we're going to add all three of these together. So your total, in the end, we're going to have to do square plus trapezoid plus the semicircle. Let's take a look at each one separately. Here's your square. With a square, you can just do the side length squared, or you can do base times height. Here we have 13 times 13, or 13 squared. So the area of the square will be 169. Let's take a look now at the middle trapezoid right here. Just did a trapezoid. We have base 1 plus base 2 times height over 2. So your two bases, one's going to be right here, and that's going to be this 30. And then we have another one right here of 13. Our two bases of 13 and 30 times the height, and they're going to go ahead and give you the height up here of 20. The height is the perpendicular distance between the bases, all over 2. When we calculate all of this, we'll find we have 130. Last one is going to be the semicircle. And we just looked at that one as well. We're going to take the pi r squared of a circle and divide it by 2. The diameter right here is going to end up being 30, so we need to make sure that we take half of that for our radius of 15. So we have pi times 15 squared over 2. And this area, rounded to the nearest tenth, will end up being 353.4. So now we take all of these together, and the total area is going to end up being, I'm going to show you guys how sometimes we write this with a little subscript. Area of the total will end up being 952.4 inches squared. All right, let's take a look at the next one. So this problem, we just want the shaded region. So above this little star thingamajiggy over here, sometimes we need to subtract if we're missing a piece. So what we're doing is we're taking this larger rectangle and we're going to remove the smaller rectangle. So to find the total area, we're going to take big rectangle and we're going to subtract the small rectangle. So let's look at the big rectangle first. Your area for a rectangle will be base times height. And we look at the whole big rectangle right here. We're going to notice the base right here. We've got 100 feet that goes along the smaller rectangle. We need to add this 25. And we need to add this 25, so we have the entire length segment addition postulate. So we got part plus part plus part. This will end up being 150. When we look at the height, here we've got 20 feet as the smaller rectangle, but we need to add this 25 and this 25 to have the entire length of 70. So we just go plug this in, 150 times 70. The area is going to wind up being 10,500. So when we find the smaller rectangle, the base and height are right here, base of 100, height of 20. So we have the exact same formula, just base times height's an easy one here. 100 for the base, 20 for the height. the area of the smaller rectangle is going to wind up being 2,000. So our total, we take the big, 10,500, subtract the small of 2,000, and the area for the total, what we want, would be 8,500. And this is in feet, so we'd have feet squared. Next, we're going to have another subtraction problem. Our geometry students already had a problem like this on an assignment. And we're going to round to the nearest tenth. And what we need to see here is we're going to have this square, and think of it like a cookie cutter. It's like square cookie dough, all right here, and we're going to take a circular cookie cutter and remove that cookie dough, go put it in the oven. How much cookie dough is left? The shaded region around here. So for our total, we will have to take the square minus the circle. So looking at the square, the radius of the circle is 12, so since this is a square, that is half the side length of the square. So we double it up to get the side length of 24. And again, with area of square, I like to use s squared. We just take that side length of 24 and square it. The square's area will be 576. For the circle, just pi r squared. That's an entire circle, and we already established that the radius is going to be 12. So we have pi times 12 squared. This area will end up to the nearest tenth, 452.4. Total, as we said, square minus circle, square 576 minus the circle of 452.4. Your total area comes out to 123.6, and we'll just put it as units squared. Okay, so let's make sure we pay attention to this next part. Sometimes we're going to have the figures overlap, which we haven't had in the previous 4 problems. When these overlap, you have to figure out which parts to not count twice. So in this problem, find the area of the shaded region formed by 2 overlapping congruent circles. So these 2 circles will be exactly the same, and the square. So what ends up happening is this area right here, which will be 1/4 of the circle, and this area right here, another 1/4 of the circle, we need to take away. We don't want to count it twice. When we find the area of both circles and the square, it's going to add this part and this part in there twice. So what we have to do is make sure that we don't count these twice. So I want you guys to see is if we have 2/4, that makes a half. So after we find the total area, we need to make sure that we're going to subtract half of the circle's area. If it's sounding confusing, let's go step by step here. The total surface area of what we want. We're going to take the area of the square that we can see in here. We're going to add 2 circles, okay, because we've got 2 of them. Once we do that, these shaded where I drew the lines in, we have to take that away, okay? So we're then going to subtract a semicircle or a half circle. We'll see exactly how this is going to work. Let's go ahead and start. Square. I'm going to take the side length and I'm going to square it. The side length of the square we need to see here. 4 is from here to here. And then we have the other part, 4, of the radius of the circle, making the entire side length 8. So we do 8 squared. Area of the square is going to be 64. For the circle, our radius right here is 4. So we plug that into pi r squared. We have pi 4 squared. We wanted the nearest tenth on this problem. So your area will be approximately 50.3. So now we're going to do for the total. We're going to take the square, 64, plus 2 of the circles, 2 times 0.3, and we need to subtract half of the circle that these two little pieces of pizza or pieces of pie create. So what we can do is we can take the area of the circle and just take half of it or divide it by 2. This is one of the tougher ones when you have that overlapping. We plug all of this into the calculator, okay? Our total final area will wind up being 139.5 inches squared. If you're having troubles with this overlapping one, go back and watch it, or please ask your teacher for some additional help, and maybe your teacher has another way of explaining it.